Well,
So
yeah.
I can also share one thing which we discussed the other day. I'm not sure whether I can share the screen.
Sure.
Just
Can I make host? Here we go. Okay. Here we go.
okay. Let me see. Where is it? Okay. So you can see my.
Yep, again.
All right. So this like clinical M data distribution. All right. So this is okay. Regardless this the content. If we just look at this distribution, M0 is like 600 plus, M1 38 and 933 and so on, right?
Yes, yes, yes.
And for any prediction, this will be extremely hard, regardless what kind of content inside. Yeah, the reason is that we call it imbalance classification. So it's basically one class dominates everything, and the remaining have very few, right?
Yes, yes.
So the reason is that for all this kind of prediction, right? So we have a ground truth label Y for input. Let's say input is X.
Yes.
This report, right? Output is a label,
Yes.
Which is Y, all right?
Yes,
So
yes,
we
yes.
train a function fx to predict kind
Y.
of predicted Y.
Yeah.
Predicted Y, right?
Yeah.
So we try to make the predicted Y and this output Y the same.
Yes.
Right. Then it basically try to learn that the classifier will try to learn that if try my best to make these two the same and to give 100% accuracy, right?
Correct.
But then if the classifier says that if I make everything M0,
yes,
I can achieve a nearly 99% of accuracy.
yes,
Yeah, then it will stop there. So it means that it will just try to make everything M0. Yeah, so regardless, you have all this like M1, M2, all these things, because there's a minority, right? So if I just put all this as M0, I'm making accuracy like 1600 over 700. I already get a very high accuracy, right? So this basically the so-called imbalance classification problem. So unless you have a very, very clear kind of a distinguished point, then you can make a kind of a classification. Otherwise, this is going to be very difficult.
Can I rephrase your problem statement by telling me you do not have enough M1 and the rest distribution in your sample size to actually learn?
Okay, the thing is that this distribution has to reflect the reality, right?
Yes.
If in reality it is indeed that like M1 onwards will be very, very few, then this is the problem. Yeah, I mean, it's the same as, I mean, I'll give an example, right? Like the credit card fraud detection. So they try to detect which transaction is fraud. But millions and millions of transactions are legitimate. Only probably one or two are kind of a fraud, right? So this is a reality. So when they try to predict, it's going to be very hard. That's why it's hard to like stop the fraud transaction in the credit card transaction. It's the same thing. Yeah.
So it's not that, no, okay, this is actually an easier question for me to answer because I thought the other one would be, I thought the question you had was actually harder. The answer to your question is very simple. In fact, this would be the true distribution because as you know, we are detecting more and more cancers earlier. It's called stage migration.
Yes.
So we are cutting out cancers before they spread. In fact, that's why my lifespan, your lifespan were better than our grandparents and our great-grandparents' lifespan. So the answer to your question is this would probably be a fairly true distribution. In any surgical departments, nobody cuts out of cancer when they are too late. So, and if I cut out any cancers, usually it's because I already know I can do a M0. I would never go in and cut a cancer that's MX, M1C or 1B unless the patient is bleeding uncontrollably. So most of the distribution that you see will in fact be M0. So this is actually true.
Okay.
Yeah, so that is really a question. I have only one caveat. The only caveat is there will be one specialty whose scans and clinical M distribution is slightly different in that they have more M1, M2, M3, which is the oncologist. Why do I say that? The oncologist is kind of like a dead end already. And I cannot say already, non-operable, I send to oncologists. They are like game over type. So in the context of the their population, their patient population, they will have more M1s and M2s and even MC1C, because those are the dead ends. I cannot do anything really.
Yeah.
But apart from that, any surgical specialty, breast surgery, colon cancer surgery, my specialty usually will have M0 as the dominant patient population.
Yeah, I mean, I understand the rationale is that we have to deal with this kind of a data distribution. So by the data distribution, by the nature, this is going to be hard. Yeah. So we can try the different ways, right? So of course, one easy way is that we only classify to make it as a binary classify, whether it's M0 or the remaining.
Yes.
So that we can kind of balance a bit, but still it's not a perfect solution, right? And even then, it remains imbalanced.
I would, my gut feeling, you usually have a comment about this. but I would have to go with Prof for now. Version 1 needs to be pragmatic. Maybe version 2, 3, version 1 needs to be an M0 versus the rest. What do you think?
No, my point is that, right, to make it M0 versus the rest means that the rest requires a human follow-up.
So,
but anyway, it's not a major case, right? It's not a majority. But still, we will see to what extent we are able to achieve that. Even you sum up all the remaining, it's like 9 versus 1 or like 10 versus 1. This is like 600, and this sum up together is probably 80 something. It still remains a huge imbalance.
No, there will be, and unfortunately, that's the nature of the beast.
Yes.
Yeah, I can't change that. If I change that.
No, I mean we have to reflect the reality. It just as
this is the reality.
Yeah. So that's why if the reality like this, right? So it's going to be very hard for algorithm to make a very high accuracy detection kind of prediction, because this kind of imbalance. And in fact,
can I rephrase what you're trying to say to me? The algorithm will be very hard to differentiate between M1, MNAM, M1B, M1A, MX. Because they are so small in numbers, but the algorithm should still be able to fairly pick up M0 quite well, right? Because I got so many M0s for you to sample size.
Okay, so the reality is that the algorithm will intend to predict everything to be M0. So this the key thing. Basically, that all this M1 to MX or whatever, they will try to predict as M0 to achieve the highest accuracy. So that's the issue.
You mean the algorithm has a particular predisposition to improve their own results by veering towards
so basically, it's you can consider the algorithm is basically a kind of a curve, a model to fit some dots, right? So if they fit the dots more closely, they get a higher marks. But if the most dots are M0, then we just to fit everything as M0. So they will get highest mark. Yeah, so this is the issue.
Can I say? Yeah, so for the clinical M, actually this is from majority of the result returned from radiology reports. So for this one, because one patient got multiple pathology radiology reports, actually what LinkedIn is doing is one record for one report. But in the end, when we come with the final clinical M, we have to add up all the radiology reports for the same patient together. So if we say this one will be binary outcome, then the potential issue will be if one patient got 3 reports, 3 radiology reports, because one report need manual checking, because cannot tell whether it's M0 or not. So in the end, this patient, the final report will be MX is unknown. So this one, in the end, actually the accuracy rate won't be that high.
Yes, yes.
Also,
I mean, this,
this is a potential issue.
Yes,
so what
yes.
I'm thinking, what I'm thinking is any chance we got three answers from this clinical M, if we can mark as M0, M1, and MX. MX actually is unknown.
Yeah.
So this one will increase the final result, the accuracy rate for final result.
No, so my whole point is that regardless how we do it, as long as the data distribution is like this, right? The algorithm cannot give a very high prediction. So that's basically the limitation for any kind of a prediction. So this is a one.
Yes, I fully understand. I fully
Yeah.
understand that because for our proposal, the final KPI is about reduce of manpower, the time hours, right?
Yes.
So what I'm proposing is if we reduce manual checking for certain reports, actually also can achieve our KPI.
Yeah.
Yes, if 3 categories for this return, clinical M actually also can reduce our manual checking process.
Yeah, I mean, right now we do the prediction still based on each individual reports. Of course, we have all the patient IDs can link up all the reports. Then we can produce the final kind of results, right? Let's see 3 reports from
we
the same.
didn't give to you, we didn't
of course,
give to you, but in our hand we have a primary keys.
Yeah. So basically, is that if let's say if this patient have 5 reports and all the reports are M0, then it's going to be kind of M0, right? So
yes.
But on the other hand, given this kind of distribution, we cannot expect the algorithm to give a very high kind of prediction. So basically, I try to say that the algorithm try to predict the cases as M0. I mean, it have the intention of doing that. So that's the issue.
So can I say that in summary, the algorithm got limitation in predicting clinical M?
It will say that because of this distribution, I mean, you can see the results. So there's only one case. If there is any kind of very strong evidence, you can easily make a decision. Then it won't be affected that much. Yeah, it won't be affected that much.
Yeah, but for surgery, but for surgery department, the M1 is most important one.
I mean, I understand that the problem is important. It's that the algorithm can't do much. Okay, in the other way, I spent 2 or 3 years to study this imbalance classification problem as a research. So basically, there's a 3 kind of a solution, right? One solution is that we do a downsampling of this M0, means that 600, we only take, let's say 100, so that it looks like this is 100, the remaining is the same, right? It looks like a balance. It doesn't work that much. Another way they do it is that for this, let's say M1, M1B, right? They do a duplicates. But a literary duplicate doesn't work that well. So they do a mixturing. So let's say I take 2 reports from M1, I do a kind of mix them up and then divide into 3. So I artificially create more reports in M1 so that they look like similar. So this is another approach. All right. The third approach is that that when I do a prediction, so for each input fx, I predict a y. All right. And for if I know the FX, because in training, I know where they come from. So if I know M1 is from M1, and for this, if this predicts wrongly, I give a harder punishment to the classifier. So that the classifier will kind of get more painful, right, to make a wrong cases for this minority. But regardless what approach, it won't achieve that good kind of accuracy. So this is the reality.
Yeah. So should we say we just
no, we will try our best to see how, but I mean, as I mentioned that we need to have a more realistic kind of expectation, and because the data distribution is like this, unless there are very clear indication. I mean, I give an example, like you go to an LT, that's 200 students sitting there. I ask how many girls are there. If you look at the LT and by the clothes or by the hairstyle, whatever, you can easily tell there's probably 20 girls or 50 girls. I mean, it's a huge imbalance, but still it's quite easy because the features you look at is easy, right? I mean, all the students, I mean, the girls have their own kind of clothes or hairstyle. But if, let's see, all the students are in uniform, sitting in the LT, see how many girls, and then you don't have a very clear feature to indicate them. It becomes very difficult to see by look at the LT, I see 50 girls or 100 girls. Yeah, so this is the issue, right? If we have very, very clear evidence, certain things have M1 and certain, some other things are not M1, then the imbalance is not that kind of serious. But if you don't have a very clear kind of evidence, we cannot have a very high expectation. That's the reality. Yeah.
Yeah. Can I ask Linting, how do you think when you look at M1 cases, M1 reports, do you find any significant factors you can look for from the report?
I think we actually discussed about all the MY and M0 cases. For certain report is quite clear. It means that it contains certain keywords like metastatics, as we discussed before. But some cases it's not so obvious. As you can see, we need to understand what actually report is trying to say. So in this case, it will be very hard, unless I fully understand the domain. And also, I mean, to express this meaning, people has very different written style, so it's become even harder to detect certain keywords for this kind of report.
I see.
Yeah. So that's why for
so back to thank you, Linting. Back to Prof Sun's proposal. If we go for binary outcome, M0 and the rest did manual checking. So for this one, would you have any difficulties to predict right M0 cases?
Okay. Okay, let me answer that. Eventually, as I mentioned, that the classifier intend to predict anything to be majority. Basically, the classifier basically will be trained to predict everything to be M1, unless there are some clear evidence saying that it's not M1. So that's the thing. Yeah.
So the in conclusion is these data variables is very hard to.
Yes.
Yeah. So this is the conclusion.
Yes.
So if this is the one, because we only have nearly 1 year left. So if this is the case, can we just put this hard one aside, working on other parameters first? Yeah, I fully understand. This is very hard.
Yeah, we can do that. I mean, we'll make a try, right? We make a try, but we don't want. I just mentioned that we don't want to start here. So like now we actually do So we do actually predict M0 and the rest. You see, M0 is very high. Precision recall is very high. But even this is very high, it doesn't mean it's good. Let's see, the precision is like 95%. It sounds to be very good, but if you look at the data, like 600, if you take 5%, it's about 30 cases, right? That means cover almost the rest already. So
okay, I fully understand.
Yeah. So this is the challenge. Yeah.
Okay, fully understand. We accept the challenge. Yeah.
Sorry, I missed a lot of the discussion, but because changing now I'm in OT, I got some time. I do understand that Hong and I see things from a certain view, but and Prof sees things from a different view lah. I missed a bit of the discussion. I will catch up with Hong, but I guess the best thing is we need to come to a compromise lah. Hong,
yes,
we can discuss it later lor.
Yeah, it's okay. You won't miss it because it's recorded, right?
Oh yeah, even for me. I mean, I didn't want to bring out to the toilet lah. Come on. Yes. So yeah. So I will. But you do understand this is not something, Prof. You do understand it's not something I can change, because if I have more M1s than N0s, then I'm not doing my job in terms of surgery, is it?
No. I mean, that's why the first question I asked is this real, right? So if this is real, then we have to respect to the real. Because, I mean, once let's say you have your classifiers, the classifier will fill with the real cases anyway, right? So we cannot fool the classifier. Yeah.
But I also saw Hong Hong's point
Yes.
Temporal. I hope you see Hong Hong's point a temporal journey versus it's really the difference between a column, looking at a column down, or looking at a row across. Different outcome, different results. Yeah. So, anyways, I think we can discuss this further. This is algorithm discussion now. We are creating algorithms. No easy way out of this. Oh, no easy way. I mean, we can't know this is coming. But for the rest, I hope we organize another lecture in November. Again, this time round, can I get Linting, Fiona, Elaine, or anybody to discuss, to tell me the topics? Because when it comes to the topic, I more or less have covered those that I can pick up. And I want to cover things that is useful to you guys. So feel free to feedback to me, either Hong Hong or anybody else, to see the various kind of topics that you think will help in the data annotation. Ken?
Okay.
Prof, you're the host. I don't know how. Actually, can you make me back the host? I don't know whether I can claim host. I'm the host now. Yay. Yeah. So with that, we will probably call it a day today, huh?
Okay.
Anybody got anything to raise up? Elaine, Fiona, Linting, Yingnan?
I'm fine.
You're fine? Okay. Anybody got last comments to make? Anything that you don't want to say in this forum, please approach me privately, Ken. Okay lah. With everything else, then we'll end the meeting today. Wow, it's still 2 hours. I thought I want to keep everything.
Yeah.
Okay. Ken,
Yeah, thank you.
bye.
Thank you,
Everybody
Jay.
have a
Yeah.
nice day.
Bye.
Thank you. Bye.